to you all. He has done his MS in Manufacturing Management from BITS Pilani and MMS, that is Master of Management Science from Pune University. Sir has 35 plus years of industrial experience. Now, as far as SAE portfolio is concerned, SAE Foundation, he is an SAE Foundation awardee, Roll of Honor, February 2020. SAE Western Section Chairman since April 2018. He is SAE Managing Committee member 2016 to 18. Managing Committee member of Southern Section 2013 to 15. Last 13 years, he is an active member of SAE. Now, he has submitted a paper, The New Approach of Automotive Vehicle Assembly in CIAT 2015. Actively involved in SAE Baha for past 12 years and past 9 years he has been handling technical committee. He was a convener of Baha 2014 event, Supra organizing committee member for past 3 years, SAE Simcomway co-chair for paper session and convener 2 and 3-wheeler conference 2018. Now, as far as AICT portfolio is concerned, sir is the member in syllabus formation of DVOC and BVOC in automobile courses and industry expert for evaluation process. As far as his industry portfolio is concerned, he was there in Bajaj Auto for 13 years, in Mahindra & Mahindra, Nasik and Chennai for 20 years, and he is presently in ARAI and since 2015 as Deputy Director Chakan Operations. He is an expert in automotive testing and certification, manufacturing processes and simulations, new automotive products development, testing and vehicle dynamics, all types of 2, 3, 4 and 6-wheel goods carrier vehicle development and design evaluation, rapid prototyping and tooling, IPR coordination for protecting IP rights. Sir's achievement involve planning of MRV proto shop, machine shop, body shop and labs, prototype building capacity enhanced in multiple folds, front loading of new model manufacturing techniques, hand holding with production team with providing training, ARAI test facility establishment for various labs and infrastructure, set up and comply the factory regulatory requirement and establish systems. So I would like Sanjay Nibandhe sir to kindly take over the session from here. This was a brief introduction which I was able to give about you, sir. But we know your vast knowledge, the depth of the knowledge, we would be gaining a lot from your session today. Over to you, sir.
Siddiqui sir, thank you for your kind words and giving me opportunity to speak to all of you. I would like to start with some introductory part and then I will switch over towards the my topic particularly. Being ARI, being SAE, I would like to spell it out that all the faculties who have joined for this program, I welcome all of them on behalf of ARI as well as SAE India. You may be aware that SAE India is the large portion which is handling about knowledge dissemination and in the all three categories like students by having the experiential learning, for faculties identifying those gaps between the industry and the faculties academia parts and trying to bridge that with conducting the FDP programs which we have done so far so good. Almost about 4 or 5 has been done and we kept on talking in various forums on all such matters for the knowledge dissemination part of it. Similarly, from ARI side, ARI is very much supportive for academics to develop. You have already heard to Dr. Vora. He is our one of the senior member in ARI. Of course, he was also a chairman of SAE Western Section, and then subsequently I took over from him as a SAE part of it. But looking forwards for the professional development, SAE is coming into picture of 25 years of continuous efforts, and now we are having a lot of opportunities to see that the programs which can be helpful for all those professionals to get developed. And for your information, about 80 programs during this pandemic period has been conducted, including the design and development of e-mobility vehicle for the sake for all faculties as well as the professionals. Lot has been discussed on e-mobility part of it. Plus, we had got other topics also which are connected with the industry requirements, which have been taken up as a advanced processes for hybrid vehicles, transmissions, and all those design requirements. So, looking forward for all such inputs, my sincere request to all of you to promote for SAE. You become a member. Your HODs are requested to be a part of this SAE. And being 25th year of this SAE, we should be having all those benefits for our individual development as well as the leadership developments. All those things are very much feasible for all of you. Now I will turn to my own topic. I will request for giving me a presentation rights.
Sir, sir, you can share your screen. You have
Okay.
the right.
Yeah. I'll take up my screen right now, and then we will start discussing. If you feel like something has been already talked by Dr. Vora, probably you can hold me back asking that this has been covered so we can switch over to the next point as well.
Sure, sir.
Just give me a second. Give me a second.
Sir, when you're sharing, just go for screen one, desktop, so that we will be able to see everything.
Screen one.
Yeah. Left
Okay.
side, extreme left, when you press the share button.
Okay. Just give me a minute. I'm not able to share the file which I wanted to share. File is kept open. अरे जरा वर 1-2 मिनिटं.
Sir, shall I help you from here?
Yeah, just trying to see. I have kept my file open. However, PowerPoint I could not showcase in the sharing part of it.
Sir, what you do now, just next to the mic button, now you will find that up arrow.
That is there. I tried for that. Then I do normally this type of activities frequently.
Correct.
However, when I open this, I'm not able to see the open file from my side, my desktop.
Okay, you have to share only the desktop screen. The extreme left.
Desktop screen. That's what I'm trying to do.
Not getting.
Let me take some little technical help.
Okay. Sir.
ये लवकर हे बात हे जे ओपन करतोय मी डेस्कटॉप शेअरिंग करायचं मला हे डेस्कटॉप शेअरिंग करताना मला
Sir, we can see your screen.
Okay, fine. Then I'll continue with.
Sir, just yeah, go into the show mode.
Yeah, I'm making it. Can you see?
Yeah, yeah, it's visible now, sir.
Okay, thank you. Once again, good afternoon to all of you. Overview of e-mobility and future trends. I think the title has been changed for the purpose. Then what I'm going to cover is on
Sir,
e-mobility
just
side.
sorry to disturb. Just a request, you just minimize my video that is coming over there. Yeah. So full entire screen will be visible.
Okay, fine.
Yeah. Thank you, sir.
Okay, I'm going to cover on the e-mobility part, then future trends, and how is that e-mobility with hybrid and the fuel cell will be converted. That's what we will be discussing on it. Let's see a couple of things. Probably this National Electric Mobility Mission of Plan 2020 is helping us, and FAME is the area which is promoted by government, is helping us on the technological development, demands, and the pilot projecting and charging infrastructure. So there are the four focus areas which have been planned by government, and this program is being driven by the heavy ministry as well as the Ministry of Road Transport. And there are certain incentives. Probably this might have been covered by Dr. Vora. In case not, you can have just go through it. And there are different incentives has been planned for introductory of the e-mobility vehicles in Indian scenarios. So people are really getting benefited by reduction of the price of the vehicle. I'm saying price of the vehicle, not the cost of the vehicle. And of course, the challenges like EV policies in a couple of states have been very much liberalized, and they try to help you out by giving those benefits to the manufacturers of EV vehicles. So I'll not read it out directly, but you can make it the point to understand. Sir, you can give me feedback if the voice and modulations are okay with you.
Yeah, it's going fine, sir.
Okay. Now from FAME, Niti Aayog is also helping us by giving us the projections that what is that expected out of 2030, and people are talking about that energy consumption is going to increase with current scenarios, and how is that transformation from electric vehicles or shared vehicles or connected vehicles which is going to help us. So probability of CO2 emissions which have been very harmful for the individuals is likely to come down, and by use of more and more electric mobility or shared mobility. So this area is basically from various perspective of projections which have been given up by the government. The electric car is shock surpassed, and 2 million vehicles are already there in the 2060. Then various countries such as Norway, Netherlands, Germany, France, UK has set their targets for 2030 that they will convert 100% vehicles with e-mobility. India is also focusing on electrification for transportation. The various vehicle manufacturers such as Volvo, Daimler, Volkswagen, they have already announced their plans to come in India and start manufacturing those vehicles. And you are well aware that Mahindras and Tatas, who are a pioneer in India for their vehicles as an Indian manufacturers, also came up with their versions in e-mobility part of it. The forecast by international energy agencies for the global outlook for 2017 report says that there should be about 70 million vehicles by 2025. And World Bank says that it will stop financing for upstream of oil and gas projects. So from 2019 onwards, they have already stopped their funding to development of the basically oil and gas related projects. So that is how focus on electrification is being given. Auto rickshaws, e-autos, taxis and buses is the major area where the public transportation will be deploying with electric vehicles. And today's scenario, the getting electric cars is said to be a challenge as on date. However, we can say that more than 10,000 EVs have been put in the market. The funding of 11 cities in a public EV and multimodal transportation has been already introduced, and there was a news about a month back that more than 500 vehicles will be made available between Pune and Mumbai for those metropolitan corporations to ply between the intercities as well as to intra-cities transportation. There is a challenge of swappable batteries. Again, battery charging is taken as one of the major inputs for electrification, and for such matters, the swappable battery is the solution which has come forward to see that more and more electric vehicles be benefited with the swappable batteries. The technology wise, this is not a very new thing. As like you go to the petrol pump, you refuel it. Instead of that, you are just making the change of battery. You are not owning any battery as an individual, but batteries are taken on the rental. There will be some agencies who will be offering you the rental batteries right from the day one, and the recent law has permitted for OEMs to sell the vehicle without a battery. So that means the rental battery sources ownership is with the certain companies who are trying to rent it out, and those private service providers will be helping us to rent it out like monthly rent and give them a battery which is discharged. Take the new battery from them, put it in your car or the public transportation system, whichever you are using as a e-rickshaw, auto rickshaw, whatever it may be, and people will be able to use those with a very minimal rent for such batteries. Then private vehicles are largely leveraging on the ecosystems. Basically, the connected services which are affected with the private vehicles will be dependent on all such matters. So there is a definite program has been drawn by government, and things have been considered for this Paris climatic change agreement, then ambient air quality surveys which have been conducted in Delhi, Mumbai, Pune, and major metropolitan cities has been done. The import of oil, energy security, whatever we are talking about, large amount of money is being diverse for all such matters on importing the money, importing the oils, and solar power generation. As on date, is again the challenge which we are looking at it, because the panel cost is quite high, installation costs are very high, but government is trying to promote on those areas so that the e-mobility services can be much more significantly increased in years to come ahead. The, there are certain things which are related to electric vehicles. Drivers are there that significant emission norms, which we are aware that from change from BS2 to today's scenario BS6, which has come in last 20 years time, every time we have seen that the effect of one norm implemented in the OEM field for automotive vehicle has increased the cost of product. That is basically understanding is that every time your combustion process need to be refined, development, combustion systems, combustion post processing is becoming more and more technologically stringent, and people need to spend lot amount of time on those components to develop those components to fit in the packaging of the vehicle. And finally, that emission control, although it is definitely possible to meet, but every time it gives a lot of impact to a customer. That's how emission systems, yes, we do agree that BS6 norms are implemented already in India from 2018, and in 2020 also we see that there are good benefits are coming out of it, but impact to the customer in terms of the cost is significantly increased. The fuel economy is another challenge. The new vehicles which are coming up are asking more mileage, and to certain extent, this fuel economy is also one of the crucial parameter which is contributing on the population of the vehicles. High specific power. Earlier days, your speeds are not much high. But nowadays, with lots of the express highways which are coming in India, the golden quadrilateral, or maybe the new metros or new cities connections which have been done from various end-to-end locations like Mumbai, Ahmedabad, Delhi, then again from Delhi to Kolkata, Kolkata to Chennai, Chennai to Bangalore, Bangalore to again to Mumbai. If we take this kind of a circular routes also, the infrastructure development and the robustness which has come up through the infrastructure has helped us to significantly increase the speed. Now, with specific speed, you need a lot of power also. And with that power, probably those vehicles of 150 HP engine or maybe 100 plus kilowatt engines which have been there, which has significantly increased in terms of the number of vehicles. And that's how power and torque, then low fuel consumption, those areas are becoming more and more challenges. The NVH is another area. Because of NVH, probably people feel more comfortable, and this noise, vibrations, and harshness help for a client or customer to make their life more and more comfortable. But packaging in terms of the vehicle which is required to absorb the noise at the source, to reduce the vibrations at the source, and to almost minimize the harshness which makes uncomfortable for the passengers to sit inside, has to be almost nullify in the source level. So looking at that NVH challenge, lot of packaging material, lot of extra efforts which are really required on those specific areas has significantly gone up. Similarly, enhancing the durability. So today's scenario, if we talk about the product, one can easily cross more than 2 lakhs kilometers in a year. And if you use this vehicle for 5 years, V10 life has been covered just without saying so that you have covered that much of mileage. And so many number of examples of those vehicles kept on running for more than V10 life is becoming a significantly higher numbers as compared to the previous. If you look at those 20 years before data of those good old days of ambassadors and premiers which have been deployed on the road, probably the end of the 20 years, end of the 30 years, those vehicle has crossed not more than 2 lakhs of kilometers. But today's scenario, if that 2 lakhs kilometers get covered in just 1 year, and people, those who afford to have the transportation systems, those who offer these vehicles as a public transport, maybe at the private level, but these people cover more than 3 lakhs, 4 lakh kilometers in a year just like that. That's how durability of vehicle is a significant characteristics which is really required for the vehicle level refinement, betterment, and as well as the comfort level which has to be offered to the passenger. Then high power to weight ratio is another challenge. We always see that you need a more power, you need a lesser and lesser weight. So a lot of money has to be put in for all such areas where the vehicle weight has significantly came down from something like 1500 kgs to 1000 kgs. Those vehicles which were there of 1000 kg weight, they have come down to 600 to 700 kg weight. And those auto rickshaws and other people, those who were about 400 kgs, has dropped down to something like 250 or 300 kgs. Likewise, there is a big challenge in the weight reduction has been putting it lot of amount of money for automotive development. Similarly, the challenges of emission, noise, cost, and durability, we discussed about it, and that's how the solutions which have been looked at it is the electrification of the vehicles, which we can see. I'm just trying to showcase you some of the standards. Probably this may be the repeat portion, but I'm not going to cover it up in details. What I will all of you request, if you are interested to know about the standards, you just refer to ARI site, ariindia.com, and you will be able to download all those standards, AI standards, which are available for public information. For any reason, one can download those standards, and you can come to know which are relevant standards from this slide, that this is applicable for EVs to comply with, and people, those who are manufacturers, definitely required that kind of a certification from agencies like ARAI. So with these inputs, I would just switch over. You may note it down. This is HEV related, the hybrid electric vehicle related standards, AIS 102 part 1 and part 2, and relevant standards in ECE has been given here so that people can correlate with this and make use of it. These standards for the different hybrid vehicle, projects which have been going up. Similarly, there is a retrofitment requirements in India. In other European countries or American areas, these standards are not relevant because they never go for that kind of a retrofitment. However, in India, the utility for vehicle is being taken up to the end of the life. And all such matters, probably after 15 years or 10 years, if people feel like I wanted to use the same vehicle, but I wanted to go for the electrification. So there are certain companies who are using those vehicles, old vehicles, converting with the electrification. They have to follow this AS 123 standard and comply for all those retrofitment in terms of their classification which have been given there, and make sure that these vehicles are meeting those standards and recomply for that. As a OEM, they have to do that, and once they got a certification, those vehicles have been notified in TC's regulation so that RTOs can accept your vehicle as a change of power plant. So instead of using the gasoline or diesel power plant, you can make use of the battery operated electric vehicle as a retrofitment part on your own old car, and that conversion will definitely acceptable under the RTO conditions, provided you are buying it from the ARI approved sources. Now, how does it look like electric vehicle? So battery charger, fuel storage, then lightweighting materials which have been used in the vehicle, power electronics, electric motor, these are the areas which are predominantly required in those vehicles. You can see the schematic diagram, and based on this diagram, you can make it out that this is the how the layout has been done. So battery has been placed in the central zone of the vehicle, probably below the passenger seats, or sometimes on the floor level. You may be aware that Tesla floor level has been completely occupied by the battery. The entire section from the driver's cockpit to the passenger's area completely occupied with the battery. That is a lithium-ion battery cells. They have arranged in a such manners that they have been placed there below your foot level, floor level, and below that they have made the proper packaging so that water entry restrictions and all those safety precautions has been taken care. The charger is another area which has to be considered as a significant requirement, because your charging system from 2 hours to 8 hours, whatever is required for all such matters, you have to have a charger which is onboard charger. Probably plug-in charger are helping to you to park your car inside the parking slot and then you connect it to the electric charger. Or sometimes you may have to carry the charger along with your vehicle, provided that kind of suitable systems are not provided along with the car. This is what charger looks like. And if I say today's scenario, 3.6 million vehicles, passenger vehicles have been done. About 21 million vehicles of two-wheelers, they are in the market. Commercial vehicles, about zero point 0.8 million vehicles have been there in commercial segment, and three-wheeler about 0.7 million. So that many of vehicles are getting sold in the market with the electrification part of it. And these are the couple of pictures which I have tried to show you so that easy identification of the products can be done. So particularly those red color things which have been noticed in Delhi side or northern belt, they have been well introduced in the market areas. People try to manage them manufacturing in local areas and they sell it off. Similarly, this Scania truck, which is electric truck, which has a overhead wires and it is connected like our railways, which we have seen here, electrification railways. Similar type of corridor has been planned with the current government. they try to see that this type of corridors will be made available between Mumbai to Delhi, or maybe Mumbai to Jaipur or Jaipur to Delhi, and many other segments like that, so that whenever these trucks are plying between that zone, they can make use of the charging systems which are really available without any without any certain charges which they have to pay, and they can make use of it. So carrying the batteries is challenge, but having the electrification done is considered as the best option, and those corridors are likely to get developed in India very soon about it. Now, typically, if you look at the component level, I have showcased the entire electric vehicle right from the right corner of battery pack, wherein you can see that couple of cells have been put together. From that, VPIM is a controller, then HV DC-DC converters are there. Displays inside the vehicle has been shown here. Then there are certain shifters for the gear shifting pattern, auto transmission kind of thing. I'm in a meeting. I can call you in about 1 hour. Okay. Then you can make it out that the pedal, accelerator pedal with throttle responding sensors which have been placed inside the car. Then electric motor with electric inverter connected with the motor. Then there is a ECU or VCU called as for the electric supply conditions. Then there is a gearbox which is coupled with the motor, and there are HV heaters which have been provided for the air conditioning requirements. Then there is a system for the full controller mechanism. Cooling pumps have been provided. Then relay modules has been provided, and most important and significant part is a BMS, battery management system, which plays a vital role in the entire function for the electric safety. Then HV charger is another area from where the charging connections can be tapped out, and which supplies the charging to battery. So looking at this picture, probably you can come across these many important components will be required in a typical type of four-wheeler, either it is a car segment or it is a bus segment, which can be very much essential for all such things. Shall I push it forward?
Sir.
This is a
Yes,
schematic. This is a schematic diagram. I would try to show that how it looks like, and the either front end or the rear end wheels, which is given through the gearbox, then electric module, and the controller or AC controller, AC-DC controller, or inverter which have been provided, and battery supplies to converter supplies to AC, DC-AC converter, inverter, then electric motor and electric motor connected to gearbox, which is coupled with the axle. That's how schematic diagram established for the drivetrain for the electric vehicles. I have just given some inputs to you, not necessary that it is making a significant role over here, but if you look at the lithium ion polymer batteries, which is providing you 200 watt per watt hour per kg, and that is what the energy which has been considered, specific energy which has been considered by the batteries over a lead acid batteries. So lead acid battery wise, weight is very heavy, plus you have very low charge in terms of the specific energy. Similar way, lithium ion battery is giving you just little better than the existing lead acid batteries, however, which is not considered as a very good solution. Currently, all the vehicles are with lithium ion batteries. Lithium polymer batteries are somehow they have been under the introduction. Some people have done the experimentation part and they are coming up with. But sodium sulfur batteries, if you look at the range which we are likely to get between 150 to 300 watt hour per kg, and that is a significant area. The lot of efforts for the new battery introduction under the sodium sulfur consideration is also being planned by many of the industries, and OEMs are putting their efforts to introduce the sodium batteries. In USA or in Europe, the significant amount of the research has been conducted on those sulfur batteries, sodium sulfur batteries, and which is hardly any cost as compared to lithium ion. And people are very eager to wait for those sodium sulfur batteries to come up. Then actual boost for the EVs will be very definitely available for that matter. The ultra capacitors which have been used, particularly in the space centers or space research programs, that is also being used, and the supercapacitors which are coming up, people are trying to make use of those supercapacitors to see that the good support and good extra energy can be provided through supercapacitors which are likely to come up in the market. But these values are helping you to understand from where we are going to make the comparison between gasoline vehicles to EV vehicles. And that way, the energy creation by gasoline versus energy creation by lithium ion is a way different. And that's how we see that those vehicles are already considered into the significant amount of the challenges which have been put up in the energy source sort of thing. Now, particularly conceptualizations of AV, electric motors are of two natures. One is AC type and DC type. Range between zero point 0.5 kilowatt or even less than that for two-wheelers. Something like 250 wattage motors have been used to the significant level of 600 kilowatt for the bus and truck applications. And range, if we talk about two-wheelers, people talk about 10 kilometers. That is a range. Once you charge the battery, it should deliver to you for a 10 kilometers drive, which can be happened for any small two-wheelers or the cycles or bicycles which have been used. And to the extent like 300 kilometers is being claimed by a couple of new products which have been introduced by Tata Motors or Mahindras or maybe those Japanese companies or European companies which are trying to come up in the market. But this range makes a lot of difference for all of us to see that people between intra-city travel, if suppose Pune and Bombay one trip has to be done, so you have to have minimum 300 kilometers a charge without taking into consideration that you are just touching to Pune and coming back. But if that case, if you need further charging, probably you may have to have the substation for charging, wherein you can park your vehicle for an hour or two and then do the charging, which is a major infrastructure which has to come up. But motor, battery pack, charging controller, battery management systems, these are the major products which has to go in for electric vehicle. And product wise, we have already named all those things. Probably I would not to repeat them. The added advantage of electrification is between initial level from zero start, the motor fetch a maximum power and it produces the maximum thrust or torque in the initial level. Some motors are going up to 1500 rpm. By the time it reaches to 1500 rpm, the entire thrust or the torque level in terms of kilowatt has been produced over there. And then onwards, it continues to produce the same power at the consistent rate. So hardly any changes goes afterwards. So you can see that instantaneous acceleration can happen on electric motors, which is not the case with the diesel engines or probably sometimes with the petrol engines as well. So this is how this graph is helping us to understand vehicle characteristics requirements during the acceleration part of it. These three types of motors which have been used, three-phase AC motors and DC motors. I have tried to give some examples over here, and the application has been also been given. I don't think that I need to read it out. If the visibility is clear, probably sir can confirm to me if it is good for that matter to read. So this type of motors is being used already in EVs, and I had given some examples of Tesla, Toyota Reva, Toyota RAV4, these EVs and even in Indian industry also, BLDC motors has been used in case of DC motors or the small transport vehicle segments. They have been widely using it here. This is how BMS looks like. The simple photograph has been shown from the BMS level, and how that schematic is also being shown. So cells have been arranged in a such a way that they are either in the parallel level and arranged sequentially in the series matter, so that series and parallel connections has been done for them, and the power supply from one direction to second direction is always taken up. The function of BMS is basically to monitor the temperature level of individual cell while discharging as well as charging. And thermal management is the major criteria which is essentially to be controlled by BMS pack. This BMS is helping us to maintain the temperature, to maintain the charge conditions, to maintain the charging rate, and that's how the thermal management, which is a very, very crucial in case of, I would say, lithium ion batteries particularly. This is how the charging systems are there. So you have to have the charger which is connected with this battery management, and then battery management supplies the current to the cell level and the battery level, and that is how the charging can be taken place. So from 2 hours to 8 hours is the charging capacity which we have to install somewhere, or maybe the electric vehicles has to make a provision of charger, onboard charger, so that you can plug in and get the vehicle charged. In India, typically, one more challenge which have been seen is the ambient temperature. Normally, in Europe, the ambient temperature is much lower than the Indian requirements. So, typically, areas like Rajasthan, Nagpur in Maharashtra, or northern part of the Maharashtra, or maybe northern part of the India completely, if you look at the temperatures in the summer season, which is above 45, which makes a significant difference for the charging of the vehicle, and then the timing taken for charging is increased. Instead of the capacity given for the charging won't take place in the given time, and probably you may need within 8 hours time, probably you may get about 70% or 80% charge only. So it affects to your range, and again, once the range is affected, probably the number of trips or number of cycles which you have to use in a daytime becomes significantly low. That's how the examples of public transportation systems are suffering in today's condition, including in all major metro cities. This is the state of charge and the performance and how it works with 100% charge. So, as the SOC is dependent on the V, I, T, Z, and R. So, battery in open circuit voltage, battery current, battery temperature, battery impedance, and the R is the voltage relaxation time after the application of setup. So this graphs indicates you the battery performance and battery management, how effectively it has to be used. Then cooling efficiency for even batteries, probably you may be surprised with either air cooling or water cooling will be required to provide for the batteries, and rate of charging and discharge is also plays a significant role over there. So battery management is a thermally challenge for all of us to handle with, and that's how for the large buses and trucks, this introduction of EV is becoming a definitely a part of the challenge which one has to handle with. Now, when we say about the electric vehicle safety, just second. शिंदे साहेब मी कॉन्फरन्समध्ये आहे. मी 4-4:30 नंतर कॉल करू. हॅलो सर, मी कॉन्फरन्समध्ये आहे का? आय विल कॉल यू बॅक अराउंड 4:30. या ओके. So significantly, these challenges are very well known to you. In the right side corner, you can see that roads are overflooded with the water. And these petrol vehicles or gasoline vehicles which have been used, probably having the less harm. But when electric vehicles are there with the high voltage system, by the way, high voltage system is always considered above the 72 volts. Till 48 volt systems, they are relatively safe and not having significant danger about the high voltage systems. And above 72 volts, whatever that goes up to, some vehicles will be having 244 volts, or some may be having much more than that. But these high voltage systems has a lot of significant that anybody cannot work on this. You have to have the protective equipments, protective tools to handle with, and in case of such flooded conditions, probably we may have to have a challenge that vehicle need to be protected for the leakage of current. By any chance, it should not create any short circuit. If that short circuit happens because of the water entry, the battery management will get spoiled. The batteries will get spoiled, current may start leaking through, and if that high voltage systems make some unfavorable or unhealthy conditions for us, then probably we may have the danger of vehicles which may get burned, or people may have significant shock, electric shock on all such matters. Then safety in terms of the electric magnetic interference or compatibility, what is called as a electromagnetic compatibility. So EMC EMI is a one area where one unit of engine controller or the light controller or the drive controller which interfere because of the imitations which comes out of the unit which we are deployed for all such matters. Then this compatibility should not have any significant effect, including your infotainment systems or including your music system which has been placed inside the vehicle. So any malfunctioning of those under the electric magnetic effect need to be protected properly. Then electrical safety in terms of unladen vehicle movement, then low energy standings, then uh, installations of electric kits and thermal explosiveness part of it, shock protections which has to be done. Even in those areas of crash worthiness, the last photo shows about the crash protections. So if such crash happens with any of those vehicles of electric nature, electric in drive nature, such vehicles needs more precaution than the normal vehicles, because the normal vehicles probably if you hit from the back, there's a likely chance that fuel may spill it out. But if such vehicles having an electric drive, probably you never know the wiring connection which is going from the back end with the battery which has been placed at the passenger's end at the back end, or sometimes the controller which have been placed in the back end, then the front end where the motors and other things have been placed, probably where that electric uh, earthing damage may happen, or the cut of the cables because of the accidental conditions, we never know about it. And all such matters, leakage of current is significantly contributing for all such thermal runaway or exposition to the electric discharge conditions, and any other severe conditions may occur if some kind of accidents took place in the electric vehicle. So today you just think about it that such type of precautionary requirements has to be converted much before your vehicles has been taken for the certification, and then only if this is safe vehicle will be allowed it to sell in the market. That's what you can read it out from this slide at this point of time. So limitations with EV, yes, best suitable for raw material purpose, lithium ion availability for battery manufacturing. Today you are completely dependent on China, or maybe the import of those lithium ions. Although maybe in one areas, Karnataka and Rajasthan, we have identified some lithium ion ores. However, processing of lithium ion itself is a one of the risk environment which is to be protected with. The handling of lithium ion, then disposal of lithium ion is also one of the area where we have to be concerned about it. Then battery of good quality at its price, means the better price and better quality has to go hand in hand. Today, we have to pay enormous cost, and we are not sure the battery manufactured by the local suppliers or battery sales which is coming up from either China or any other source, they are properly handled and the safety has been ensured about it. I'm going to showcase you some of the testing methodologies for it. Then range is another area between 80 to 100 kilometers is good for the public transportation systems like Zato fellows and those people who are dependent on such vehicles. But if you are trying to drive with intra-city, then probably you may have a requirement of the larger range. Then frequently charging, every 1 hour you drive and you need a charging. I don't think people will be able to do that and happy to go for a charging. So such cycle for charging and recharging, probably you have to focus on fast charging, then cycle time reduction, and then the total number of cycles to charge also should be minimized in such cases. So we talked about all the limitations on EV, wherein we have to handle these challenges. And today, if you look at these answers, probably including ARI or including any manufacturer in Indian scenarios, has no good solutions on all those areas of the challenges which we are talking about. The EV components I'm trying to showcase you so that you will be able to better understand. If you have not seen those components, try to open up any electric vehicles which have been near around, or probably I would request all of your colleges to make a note that in future we are more dependent on EVs. So we must have at least 1 or 2 vehicles at college disposal so that they should be able to open it up. Students can understand, faculties can do a lot of experiments on those parts, try to understand the drivable systems which have been used for characterizations of the motors, or maybe how that battery has been configured, which are the safety requirements, what are the abuses to it, what is that BMS, and how that people can work on the controller part of it. Similarly, charging stations is also another area, and these are the various systems and parts which have been shown for a better understanding. Space is okay, sir? The another part of the hybridization is you are aware that couple of vehicles has been introduced with micro hybrid terminology. What is that micro hybrid terminology? So energy losses during the idling were shut off, and then the combustion engines, without even touching to ignition switch, you should be in a position to start it off. So start stop controller is one of the area which is known by the introduction of the micro hybrid. Similarly, mild hybrid is recapturing the energy from regenerative braking. While you do the braking, the regeneration of energy happens, and that energy is fed to the battery for the charging part of it. That is how mild hybrid has been showcased. So, a couple of vehicles like Tiago and other areas, they have been considered as a mild hybrid vehicles. Using this battery energy to assist the engine and enable downsizing of the engine. That is another advantage today in hybrid case which has been factorized. Hybrid means it is always considered as a two fuels which have been used here. So you may use the gasoline or you may use the diesel engine along with the battery system which has been placed over here. So electric motor is also there, IC engine is also there. And in such cases, the downsizing of those engines probably from 1.5 liter, it has come down to 1 liter or maybe 0.8 liter. And that's how the new cars are coming up with the lesser weight, lesser size and lesser capacity. However, with the high power. However, with the high range of drivability. However, with the high price because of the combination of multiple drivable systems which have been placed in. So looking at this degree of hybridization is helping us in introduction of hybrid vehicles. Full HEV is running the combustion engine, its minimum load, whereas in the engine efficiency maximizes. So that means in city driving conditions, you may use the battery and no use of the combustion engines. But when you are in demand of the load or you need to have the drive at the speed, probably you can use the combustion engine. So battery will switch over to combustion engine, and combustion engine will take over as a part of the speedy drive. That is a maximum load which comes from the vehicle side. Similarly, driving without the combustion engine in city side, particularly at the low RPM, low city drive, you may drive with average speed of 10 kilometers per hour in the cities like Mumbai. But if you are in the cities like Nasik, Kolhapur, Pune, some areas probably you may able to achieve the 20 kmph speed. And that 20 kmph speed is obtainable through your battery operations, and people make the use of battery at initial stages. So instant pickup, you get it on the signals where you stop for or when you start with. Or similarly, when you go with the maximum speed of 30 to 35 kmph, probably battery is being better off without any emissions in the city side. And once you cross the city side, you are in open ground conditions or you are on the highways, probably you can change over towards the combustion engines. Then enlarging the battery pack and recharging with the energy from the wall plug, that is called as a plug-in electric vehicles. These PHEVs are basically one of the form of the hybridization, and this is one of the factor wherein you have onboard charger placed on your vehicle. So you can just connect to your electric supply, which is a domestic supply, and you will be able to do the charging of the vehicle. And you might have seen in Europe and USA, people drive the vehicles to office, they put it directly to the charging systems, and within 2 hours you get a full charge for those vehicles. Again, it is available for you to drive it back to your home. So that kind of a systems are likely to get established in India very soon. Now this is the schematic train diagrams, and what is basic electric vehicle has been shown in the left first picture. So wherein only battery, electric motor, and regenerative braking which has been considered for the axle. So you can see that these vehicles are basically only with electric motor. Here in second picture, plug-in hybrid is being shown, but meaning it hybrid vehicle, it has a two powers. One is IC engines and second one is electric and battery supply. So that is how the combination of two is going ahead with. So on one axle, probably it helps with the electric motor drive, and at some time it is either in the same drive you can establish the IC engine drive connected to the same axle, and the transmission has been placed in between. So regenerative braking also taken as a benefit part of it. So oil and fuel filling is one area, plus your charging system is another area, which is another demand for it. Similarly, hybrid electric vehicles will have the same configuration, and under the considerations of petrol and fuel tank, you have the battery, electric motor, regenerative braking, and IC engine. So combination of drive is being taken up in the both directions. Similarly, fuel cell is another introduction of hydrogen gas which can fill in the vehicle instead of gasoline engine, and which boosts up the electric charge supply to the battery or maybe directly to the motor. So that is what the fourth configuration which is coming up in India. However, that development today is not visible in front of us. So which may take longer time to introduce these hybrid vehicles with along with your hydrogen as a fuel. So hydrogen as a fuel, probably we'll see in the detail part of it when we are going to cover up that portion as well. Now, when we say the case studies which have been taken up, development of hybrid electric vehicle, its architectural program for passenger car application is the area where we have worked upon. The best possible CO2 reduction and lowest fuel consumption with integration of downsizing of engine, particularly diesel engine was downsized, and optimum level of electric drive was used under this condition. The retrofitment was also possible. Minimum weight for increase in electrical components, because the battery, motor, and the charging system, that weight is not very significantly high to consider for. Then efficient controls for electric drive and technology for the transient applications. So we may have to have the proper electrical controllers for those drives, electrical drives, so that the transient phase, normally when you switch from diesel power to battery power or battery power to diesel power, so that transition should be very smooth and effective. Otherwise, probably you may have a feel of uncomfortableness or maybe stuck up for some time. That kind of a features may make the passengers uncomfortable on that level. So features for NVH control in hybrid vehicles is another area where we have to work upon, and cost implication is major challenge which we have to handle under the hybridization programs. But as of today in India, the hybrid vehicles are not much in larger numbers because the government policies are not helping them to go ahead with the hybridization. However, to boost up the industry and the vehicle conditions, we may have to go for hybridization. Even though packaging cost is high, number of parts are high, number of challenges which we may handle to develop those vehicles definitely much more than the current scenario of either petrol vehicles or the diesel vehicles which we have right now. So how does it looks like? The energy source 1 and energy source 2, they provide a common load to the vehicle, and how that power flow is being shown here for a hybrid. Two different fuels, two different sources, and complexity increases just because of the parts increases and the total level of the build will increase into. So there are definitely benefits with this. Now, if you see the conceptualization of hybrid, this is how the transmission which helps us to optimize engine side drive as well as the battery side drive. And the transmission helps us, or controller helps us to control the speed of the vehicle at the axle level drive. These are the schematics used for understanding purpose. Okay, this is how the transmission motor which is showcased for you to understand what is the complexity, and which is little definitely complex part of it. One need to establish it, and that's how the hybrid vehicles cost will be definitely higher than those gasoline vehicles or diesel vehicles. But the added advantage which you may get it is in the city drive or highway drives you are better off. And one of the example which I would like to quote you, that Toyota Camry gives you 45 kmph average. So 1 liter of fuel and 1 liter of one charge of your battery can give you 45 kilometers of the average in one drive. So look at the benefit which enormously available on such vehicles. This is how the conceptualization of hybrid vehicles. The alternative torque and speed hybrid electric driven vehicle with a planetary gears. How these planetary gears have been placed in, and engine side drive versus motor side drive. Those are the inputs which is given to the final level in the transmission, and transmission finally transmitted to the differential of the vehicle, maybe in the front or rear, wherever it has been placed for. So these are the concepts to get established for you to better understand, and that is how the drives have been placed. There are 2 or 3 diagrams like this. The again I showcase you the series hybrid and parallel hybrid in different mechanisms, and then there will be a combination of these two, series and parallel hybrid. So these are the schematic diagrams to understand. I'm just keeping you to watch it carefully. Sir, is that timeline we are okay with?
Yes, sir.
Yeah, I have another about 20 slides for fuel cell vehicles.
Okay, no problem, sir.
This is how the hub motors have been placed. The difference here is the motor is directly coupled to the 4 wheels at the front and rear, and that is how motor drives from the supply, and engine which produces the power is fed to inverter, and inverter supplies to the motor. That is how the change of power has been considered here, and these hub motors are treated as a more efficient drives for those vehicles, and these type of drives have been placed on the large size capacity vehicles, and also sometimes in two-wheelers with direct motor coupled to the wheel, so that there is no gearbox required for all such matters. conceptualization of hybrid with parallel systems. So engine is in parallel with the battery power supply. Finally, mechanical coupler will put in to the transmission, and transmission will drive the electric the axles of the vehicle. This is how PHEV configuration model shows here. More or less, it is similar in the nature. These are two different types of the architecture which have been used in a series and parallel vehicles. How it is different, just have a look at it. One side is your IC engine drive, generator has been placed in, and generator, battery supply, motor power supply, electric motor, which finally transmit to the transmission level. Similarly, mechanical coupler transmit the IC engine power to the transmission level, and finally it is driven to the vehicle level wheel. Similarly, in the other concept, probably the power converter from motor generator, which is connected from battery side, and that supplies to the mechanical coupler. Mechanical coupler finally drives to the transmission, and transmission finally driven with the help of the axle is driven with the help of the transmission. That is how series and parallel vehicles which have been there. So you have a couple of examples from Honda, Toyota. These companies has already established couple of vehicles like Pyrus and other things. Honda Civic is there with this kind of a series and parallel examples. Now series and parallel operated as a series or parallel. Engine link with the final drive, and power to the vehicles is directly in series. Works in line with the series HEV. The second electric motor is a generator, so it is used as a source part of it, parallel HEV. And since the series and parallel HEV operate in both versions, advantages are much higher. Fuel efficiency is high, along with the excellent drivability. Drivability improves because of the boost from the battery side is always there. Provides more flexibility and freedom to operate, and quite popular versions on Toyota Pyrus or Toyota Honda Civic, those vehicles which have been there. But definitely complexity becomes very high to manage with the battery supply, manage with the IC engine supply. All those things will be definitely not easy to handle the challenge. I'm going to cover that portion also in next part of it. Similarly, the hybrid, complex hybrid conditions which have been showcased here, which is almost similar, that generator and inverter has been placed in between battery and inverter, one more inverter, and then motor drives the mechanical coupling or engine drives the mechanical coupling. And finally, mechanical transmission, which is used for the wheel to drive. The multiple motors are used for the drive, and planetary gears are involved. So transmissions involved with the planetary gears. Generally, it is used for four-wheel drive applications. So you are aware about all-wheel drive and four-wheel drive where the torque requirement is quite high. And on all such cases, the vehicles which are with complex hybrid is normally used. Then separate drive axles are used. Generator is used to perform as a series operations, and as well as the control engine for the maximum operating efficiency. Two electric motors are used to generate all-wheel drive performance, and same time it supports for the regenerative braking. So one is power feedback to the regenerative braking is being also captured here, and this also helps in enhancing the vehicle stability and anti-lock braking. So that means the rollover and anti-lock has to taken care by the better stability of the vehicle. Since the balancing of this electric system has been done in a complex manner, the system stability from the overall looking at the diagram, which is generally placed over the vehicle level, is showcased here. So front and rear is properly balanced, and the weight balancing helps you for a better handling part of the vehicle. Now, hybrid powertrain development is another challenge. I would like to just compare it. I would not give you much of the details about it because it's a complex condition for which in a OEM probably you need to spend something like 6 months to 1 year to develop the complete powertrain. And the similar challenges what it happens in the gasoline engine or diesel engine, for those drivability patterns, those handling patterns, those acceleration patterns, or those braking patterns which need to establish in the same line, and those softwares which have been used, they are objectively and subjectively evaluated, so that vehicle which are available for this type of developments, people need to have meticulous time plan for all those developments and see that significant improvement which can be acceptable to a customer level. So these programs definitely have a larger scope in terms for the OEMs, as well as the, even if the colleges tries to open up, these are the software driven analytical approach wherein people need to spend a lot amount of time for development of these vehicles. So I'm just trying to showcase some of the results and some of the analysis which have been taken care. So base vehicle performance simulations, the cruise is the algorithm which have been used here, and ARAI also done a lot of experimentations on those areas so that each and every parameter is optimized to their fullest level. And as I told you that between 6 months to 1 year down the line, probably the timeline we need to dedicatedly work on all such developmental cycle. I'm just trying to showcase you some of the performance characteristics, and with reference to your vehicle mass, what is that characters which you have to have, gear shifting patterns which we have to establish for smooth driving, probably the EUDC cycles which have been placed for the engine performance operations. Similar way with the electric drive, how that drive can support you for the engine as well as in battery conditions, that has been also verified here. And I would say that industry need a lot of amount of time and money to be spent on all this developmental cycle. Similarly, the challenges like reduction in gases, the emission gases, and similarly the hybrid powers which have been developed. So the base acceleration or the drive-through gears, which needs a lot of performance evaluation requirements, and that's how the people has to work on it. It is just to understand what are the things required to do this. But a team of about 5 to 6 engineers continuously work on all such matters in the OEM level, those who constantly working on the improvement of the vehicle. And unless and until the certain people, those who are a jury people, they try to verify as a subjective driver, and then it is taken for the customer's drive in the next phase of it. So AC/DC inverter topology, how it looks like is being shown here. These are the two methods, DCT method and FOC method, which have been used for simulations of those hybrid vehicles. I will not go into the detailed part of it, but I would just run through a couple of slides and then we will take the next part of the fuel cell part. The fuel cell development was also started quite long back, and under the fuel cell, the Pratt & Whitney was one of the company who utilized the space aircraft fuels for those fuel cells, and they try to develop those vehicles. The source of hydrogen storage in the mechanism, you can see those pictures are available from Europe or USA to see that the hydrogen vehicles have been already done. They are on to the level, but there are many more things which has to come up as a proven part in next generation of the vehicles which are likely to come up. But ethanol, methanol, those are the areas where we are aware and we are also doing a lot of experimentation. But hydrogen per se, other than IIT Chennai and IOC at Delhi level, they are working on those projects. ARAI is also part to it. But these are under the developmental side of Indian requirements today. So economical reformation of technology for hydrogen production, because producing the hydrogen and carrying it out is a big challenge. Then pressurized tanks required for the gaseous hydrogens. Then advanced carbon metal absorption, including carbon nanotubes, the storage of hydrogen, which tries to eat up the metal containing part of it. So likely erosion of the metal containers is very fast on all those hydrogen storage. So alkaline drop carbon nanotubes and graphite nanofibers are being planned for development of those areas for the storage of hydrogen. Higher technology implementations and operating costs due to the lower volumes. Today, we can't give any challenges about the numbers or the vehicles which is likely to come up. So the volumes will be definitely very low in the initial stage. Even in USA or Europe, they have not been spread with a larger numbers as on date. This is how fuel cell vehicle looks like. The yellow color two cylinders are shown as a gaseous state hydrogen which is stored inside, or there can be alternatively metal hydrides which can be placed. But if you place the metal hydrides, challenge is the weight and hydrogen storage under the pressure of 600 bar pressure which you need to store. Again, the temperature for operating zone is also another area wherein we may have to have the some more challenges to face with. But this is how the schematic diagram has shown for better understanding of the FCHV vehicles. Fuel cell categories, there are 5 categories: alkaline fuel cells, then I would say the phosphoric acid fuel cells, molten carbonate fuel cells, solid oxide fuel cells, and polymer electrode fuel cells. So PEFC is another area which is fifth one, is the major area wherein lot of work has been done. And item number 4, solid oxide fuel cells, is area where the challenges of temperature is yet to mitigate. But these two types of examples has been shown in Europe, USA, being the producer of the fuel cell to support for the electricity generation. How it generates the electricity, that much portion I am going to cover it up, and then we will see advantages and disadvantages about it. Sir, I may require another 5 minutes only, but we will try to cover it up by 14:10.
Yes, sir.
Yeah. Based on the type of electrodes, these 5 types, which categories which we have seen, based on the type of fuel and oxidants, I had shown you another 5 examples of it. And based on operating temperature is another classification which is independently happened. नाही मी अजून कॉन्फरन्समध्ये आहे. एक 10 ते 15 मिनिटं लागणार आहेत मला. या ओके ओके येऊन भेट, काय हरकत नाही. या so I have given you the examples and the temperature range for all these 4 types, and based on this solid oxide fuel cells, the stationary application has been factorized for the power generation. There are many electric fuel cell plants has been placed in USA at university level, and they are trying to produce the power as a stationary applications. But in case of this PEFC areas, couple of cars have been developed with those areas of hydrogen usage. In the gaseous conditions, they try to use this fuel as a hydrogen, and they try to couple of automotive examples in this case. How it looks like, the SOFC can be used in the form of range extender to the present electric vehicles, but that is in secondly still in the experimentation level. Nissan has made one of the model, but that is still not very successful. They introduced in Brazil, but that is, as I said, it is yet to establish in the market properly. Then the proposed solution seems to be very encouraging and promising, mainly due to the presence of onboard fuel cell for the charging of the battery, and hence user will not have anxiety of range. So when it is considered as a, you have already driven for 200 kilometers and you wanted to make use of another 100 kilometers, the range part of it, probably solid oxide fuel cell is a best solutions to this case. Likewise, you increase the temperature with initial running, then start using the fuel cell, and fuel cell supplies the electricity to your battery so that motor can be driven with that kind of a cell. But initial level, you cannot use it. That is a primary understanding about it. Then cheaper, being the proton exchange membrane is used as a fuel cell part of it, which is widely used in automotive applications. However, what is this proton exchange membrane? Is a solid fuel cell are widely used in automotive applications. Larger fleet of city buses are being used with the PEM, and the operations and implementations of the cost is almost 3 times higher. Although these buses have been driven with a fuel cell, with hydrogen supply, and recharge can be extended to work on the reduction of cost with the minimum fuel economy. So research is going on all such matters to develop further on the PM sort of thing or solid oxide fuel cell kind of thing. In both the cases, sizing of the systems like battery, inverter, supercapacitor, fuel cell, along with the optimal control strategy for the driving of cycle is the main challenge. So today we are not seeing the good example which is ready solution available for the end applications of your requirement is readily available. So that is how people are still struggling on those development side, and people need lot amount of time and experimentation to be done for all such cases. Second important aspect is economic vehicle development. As the cost is very high, we will see what it happens in the part of the converter of the energy. Now you can see how PEMFC is being shown here. The outsider plates which have been strong enough for the cathode plates. Then cathode and anode plates have been placed at the end of it. Then graphite plates have been placed inside. And then there is a gasket shown with the yellow color. Then there is a gas diffusion layers. This is particularly made of some special materials. So gas gets diffused from here and then separation of gases can take place. Then there are certain gaskets available, and MEA is the central part which converts from electron to proton as a part of the conversion in fuel cell. How it looks like and how the functionality takes place. Solid polymer electrode has showcased with the dark blue color in the center thickness with 200 microns of the thickness. Then catalyst has been shown from both sides of the solid polymer electrode, and thickness is of 5 to 10 microns. Then there is a gas diffusion layer. So you have to have the separation of gases by diffusion layer, and thickness is between 235 to 427 micron. Then flow channels are there from where the hydrogen will pass from one end, the air will pass on from the other end, and then with the reaction method, you get anode and cathode charge with the electron making the free plates part of it. Then bipolar plates have been placed around it, and that is how significantly shown in case of the fuel cell structure part of it. So working principle, fuel cell is a device that uses hydrogen and oxygen to create the electricity and electrochemical process. A single fuel cell consists of electrodyne sandwich between two thin layer of electrodes. That's what we have seen in the diagram. Then hydrogen or hydrogen-rich fuel is fed to the anode where a platinum catalyst, but platinum catalyst is the most expensive part. That is, you are aware that it is more expensive than gold as well. So such catalysts are required to place with the platinum metal, and hydrogen's negatively charged electron from positively charged hydrogen ion is separated out. Then both the cathode oxygen gases is converting into water form and forced through the catalyst from two oxygen atoms, each one with a strong negative charge, and negative charge attracts two hydrogen atoms through the membrane and combined with the oxygen atoms and two electrons, which gets converted into a water molecule. That is how the reactive method comes up, and finally the output is from hydrogen, you get the exhaust gases as a water molecule out of it. Working principle again continued with electrons from the anode side of the cell cannot pass through the membrane to the positively charged cathode. They must travel around it via an electric circuit to reach on the other side of the cell. This movement of electron is an electrical current. That is how the electrical charge gets developed over here. The amount of power produced by the fuel cell is depend upon the several factors, such as the fuel cell type, cell size, temperature at which it operates, and the pressure at which the gases are supplied to. So you need to supply the gases, you need to supply the uh, atmospheric air, and similarly hydrogen from another end. Still, a single fuel cell produces enough energy for only smallest application. Therefore, individual fuel cells are typically combination of series of fuel cells in the stock. So I'll show the picture for the next level, which showcase that the fuel cell is a combination of multiple stacks together. A typical fuel cell stack may consist of hundreds of fuel cells, like the cells of the battery which have been placed together in series. There are the fuel cells which are placed in the series. Here it showcases the schematic diagram of an electrical reaction part of it, which I will not read it out. You can go through it and just give the couple of seconds for this to understand. So finally, reaction comes out: two hydrogen atoms, two oxygen atoms, and it works out to as a reactive part is a water separation, which comes out as exhaust gases, and electron flow will happen through, and finally it connected to the battery. This is how the picture of loads fuel cell has been shown. One fuel cell generates only 0.5 to 0.65 volt. That is much smaller than the smallest button cells which you are using it in your calculators or the electric watches which your people are using it. So look at the size of the cell and look at the fuel cell size which is comparable with. So voltage generation with fuel cell is quite low, but when you couple them in thousands numbers together, probably that is the size which people will look for the development of the fuel cell. Like, I'll switch to the next slide. Then industrial usage is passenger cars, public transportation, city buses, locomotives. Niche areas is yet to come up. Aerospace industries, they are using it with supercapacitors. Power generator sets, then material handling equipments like forklift, warehouses, locomotive for the mines. Then portable applications, laptop charger, mobile charger, micro power supply to electronic equipments. So this is how industrial usage is being taken up. Similarly, solid oxide fuel cell is another criteria which we can look at it. Work on the higher temperatures, they uses a solid ceramic electrolyte, which is a zirconium oxides sustainable with the lithium oxides instead of liquid and operate insisted of the liquid and operate at temperature between 800 to 1000 degrees centigrade. So it has a preheat requirements in any case. Solid oxide fuel cells negative ions travel through the electrolyte and anode where the combined with hydrogen to generate with the water and electrons. The efficiency is around 60%, that is the highest level which we can see from the fuel cell, are expected to be used in the generating capacity. So generators, power generators is being widely application for that matter, and heat in the industry and potentially for the providing auxiliary power in the vehicles. So you may give only boost up power, but basically on the power generations areas where the temperature are quite high, they can make use of the solid oxide fuel cells. This is how it looks like in a schematic diagram, and reaction has been shown here. At the cathode, oxygen modules from air are split into the oxygen ions with added or 4 electrons. The oxygen ions are conducted through an electrolyte and combined with the hydrogen at anode, releasing the 4 electrons. So that is how oxygen and hydrogen comes together. Finally, it works out as a free electrons, 4 electrons, and cathode reaction happens with the oxygen to make it free. And finally, overall reaction becomes a conversion to the water with free electron flows. That is how the circuit is connected with the SOFC. Advantages and disadvantages, I will not read out, but the efficiency is considered as the highest. Operating temperature, cogeneration applications for create high pressure steams is one of the areas where it is being used. Tolerate relatively impure fuels. Fuels may not require as a very fine level of the fuels. So gasification of coal or gases from the industry process is also being used. Higher temperature operation removes the need for the precious metal of catalyst. So being the temperature is high, you do not require the cathode material, which is very precious material as a platinum part of it. Then they are not poisonous by carbon monoxide, and they can even be used as a fuel part of it. Sulfur resistant is there, allows SOFC to use gaseous modules from coal. Different fuels can be used for this purpose, and scientists are currently exploring the potential for developing low temperature SOFC operations between 800 plus minus degrees that have the some durability for the future and cost reduction part of it. Similarly, drawbacks are significant time required to reach operating temperature. That means preheat temperature is definitely a high time consuming part, and high temperature requires more expensive material of construction. That means the shell which has to be built in, which is definitely sustainable to 800 degrees. That is where the construction cost goes up for this type of solid oxide fuel cells. Now, some of the disadvantages of fuel cells is CO2 discharge with methanol reformation, little more efficient than the alternatives. Technology currently expensive. Many designs issues are still in progress, like yet the final solutions are not available. Hydrogen often creates using a dirty energy like coal and being other use in that area. Then pure hydrogen is difficult to handle, like you know that storage of hydrogen is challenge. Similarly, hydrogen itself is an explosive gas which one need to handle very carefully, and if any explosion to hydrogen, it is like atom bomb which can be shelled out, like Japanese example which have been placed in the Second World War. So we have to be very, very careful on handling of hydrogen. Refilling stations and storage tanks are all those are the question mark as of today. So I would say that the technology is known to us, technology is available for usage. However, how to look at and how to make use of it is the challenge for all of us. Now, water discharge is no emissions gases. Natural resources of fuel can be prevented, like you don't need those crude oil or gasoline or even diesel for that matter. They produces zero and very low emissions, especially greenhouse effects are very positive on that side. Have fuel moving parts. So very few moving parts are there. The required minimum maintenance. Then modular in design, so you can add on and make compactable solutions for this. This can be utilized for combined heat and power purpose. Further increase in efficiency of energy production is one of the things which is a major advantage to it. As a summary, I would say fossil fuels are going to end, so we have to be careful on the usage. At present, EVs has good potential with many hurdles to overcome. Then hybrid variety of solutions are available to boost the electrifications. So ultimately, we are going to be dependent on hybrid vehicles and overcome the issues of pure EV vehicles as a range part of it. Then hybrid will get established very slowly because of the cost part of it, and then the overall development cycle time, overall complexity which comes up. Then fuel cell is another future area. Probably we may have to wait for another 10 years to see that the good examples are available in India. Then fuel cell is extensively supportive for EVs. Again, it is just boosting your energy to the batteries and development of hydrogen storage challenges with all boosting up EV for a long run. So that is how summary talks about it in overall. And optimum electric drive control strategy, which can be downsizing IC engines. That is a inherent benefit which we can get with the hybrid vehicles. Use of advantage simulations of algorithms are required in formulating and testing of those hybrid vehicles is another perspective wherein people need to do a lot of experimentation, and there is a scope for specialists to develop in future. So depending on the electrification strategy, has resulted in IGS-based parallel hybrid vehicles, and the architectural is being developed. That's how overall summarization has been done. So EVs are there. Probably in future course, next 5 years we will have hybrid vehicles, and in future we will have the fuel cells, as like the challenges and advantages we have seen in overall. That's overall from my side. Now over to you.
Yes, sir. Thank you very much. I'll just take up questions. If any participant would like to ask any question, you can put it in the chat box. I will ask that question to sir. And in case if you want to talk to him, you can just raise your hand. The raise hand option is available next to the chat icon. So just raise your hand so that I can see you and unmute you. Yeah, hello participants. You can ask question, or else I will just thank Nibandhe sir for this excellent lecture. Just a minute. So there is one question, sir.
Yes,
why
please.
cannot we use BLDC motor for electric vehicles?
It is being used. Why we should say that it is not being used? It is widely used in electric vehicles.
Okay.
All these applications of this public transportation auto rickshaws, they are using BLDC motors only, and that too in the capacity from 1 kilowatt to 2 kilowatt. They are widely used in all these applications, and there is no restrictions about it.
Okay. Another question is from one of the participants. We wish to know about the legal procedure for using retrofitted EV.
Legal procedure for retrofitment of vehicles as a OEM or any manufacturer who wanted to go for a retrofitment part, he has to select the components like batteries, then you have a controller, then you have a motor which you will be using it, then you get it tested as an independent component, and then in a permutation combination, when you showcase the diagram how it has been placed and how it has been safely manufactured for considering all the risk level from the battery level kind of thing. So as a manufacturer, he has to come to ARI, he has to apply his mind with the standards which are shown you, with those AI standards, retrofitment standards applicable to the specific category, less than 3.5 ton, about 3.5 ton, and then the commercial vehicles. So accordingly, he has to make use of the standards, and if it meets the requirement, the manufacturer will get a certificate that as long as he used to produce the vehicles with these components, this is a certified component level certification is definitely required, and then he can approach to transport commissioner in the state, who will notify in his gazettes, and finally RTOs will accept your vehicle as a retrofitment vehicles. So there's a procedure is not complex for that matter. It won't take more than 6 months in totality, and cost wise also it is not very significantly high as like producing the new vehicles, because you are basically using the braking systems or safety systems which are already established in the old vehicles. So on extension part, whatever the retrofitment is required, that much of portion will be checked for such matters.
Okay, now there is one message from participant number 152. He is saying we have got lots of EV projects in campus. Can I request him to unmute himself and speak over here, because sir is also present. So at least we can have a discussion, or we'll know what projects are going on and where is the campus. Participant number F152, I have allowed you to unmute.
Hello everyone. Hello sir.
Yes sir.
Sir, I am Akash Dubey from ITM Universe College in Vadodara, Gujarat. And we have been in a position to make a lot of projects under this electric version of our automotive industry. And as there are no such curricula courses wherein we have subjects of the sort which we are being discussing since morning, and only through research papers and some Google searches we are able to make these EV projects in our campus. And while doing so, as you rightly said, we procure components which are ARAI approved, and then we use them in our projects. So there are students which are asking that can we go for startup with these projects? Can you please point out on that?
Yeah, you are talking about two parts which I grossly understood. One is the project work which you have taken it up, and there is no curriculum available for that. That problem probably Dr. Vora can help you out because he is already into that syllabus committee for the skill development part of it. So he has continuously working in that area, and you can tie up with Dr. Vora to get that skill development solutions at your college also. That is one of the way you can tie up for syllabus and having the curriculum based activities for that matter. Second one is you are talking about the startup activities for which you need definitely some support, and in such cases those persons who are connected with can be diverted to ARI. There are certain teams who can place you and support you for all such matters, and our people from ARI side can guide them what is that certification required, how they can handle the activities, and once the meeting has taken place, probably from Chakan itself, I can support you for all such activities to establish. But it is not a big deal to do with. So I definitely assure you that if you have any specific things, you can note down my mail ID, which is Nibandhe Nibandhe .cp @araiindia.com. Probably, sir, you can pass it on my mail ID to all other people, those who are looking forward for such guidance. We will be
Yes,
able
sir.
to certainly help them out, and ARI would be happy to support on all such programs which is being taken up.
Sure, sir. I'll pass on that email.
सर एका मीटिंग मध्ये एक 10 मिनिटात कॉल करू का? सर एक 10 मिनिटात कॉल करू? 10 मिनिटात कॉल करू का? मी कॉन्फरन्स मध्ये का? एक 10 मिनिटात कॉल करतो. या.
Yeah. Another question connected to the previous one for BLDC. What is the status of FAME program? One. Second one is why induction motor is preferred over BLDC. That is one of the questions.
See, for quick drives, BLDC motors are being used, and those point-to-point transportation who are not looking for a longer mileage to be covered and the range which is required to be covered, they are going with the BLDC motors. Induction motors are definitely costly. They are in long duration. They are useful with a continuous performance, and all such matters for the car programs which have been taken up. They are using the induction motors. That's how induction motors are more reliable for longer duration of cycle and as well as the range which you are looking forward for. So that is how both the motors are useful. The applications are different, and for different applications, different purposes, you have to select the motor what is suitable for your application part of it.
Okay. Sir, the same person has asked, what is status of FAME program?
FAME programs are very much there. I have shown you the incentives which are offered under the FAME 2. FAME 1 has been already closed now, but FAME 2, certain incentives has been provided, including two-wheelers to bus and car programs.
Okay.
They are very much live, and next 2 years it will be available.
Fine. Is there any industry which is working on fuel cells?
Not yet. I have quoted you 2 examples, IIT Chennai as well as IOC. They are working on the fuel cells, but that is in the experimentation level.
Okay. Any other participant, if you want to ask the question, kindly type immediately, or else I will be closing this session. Okay, sir, I think there are no more questions. Okay, fine. There are no more questions. Sir, I'll take this opportunity to thank you for gracing this occasion by your presence and sharing your deep knowledge with us. And definitely not only me or my team, but the entire participants would have gained a lot. Value addition will be there after attending your session. And in case of any other further queries, I will forward it to you. And your email ID has been put by one of the attendees, that is nibhand.cp@arai.com. So that is now shared with everybody. So in case anything is there, we will communicate to you. Thank you, sir, for taking out so much time from your busy schedule. And we'll be keeping in touch as far as SAE activities are also concerned. Okay, so thank you, sir, very much.
Thank you very much for this opportunity and really patiently listening to me. And it is always welcome to have any kind of doubts and clarity which is required. I'll be there to instrumental for all of you to support for all those activities to establish at your college level. And we definitely support for all such programs at individual capacities as well.
Okay, sir.
Thank you.
Thank you, sir, for your
Thank you.
informative session. Thank you. Definitely will interact with you.
Thank you, sir. Thank you.
Participants, please wait. Some important announcements are there.
Sir, can I leave now?
Yes, yes, sir.
Thank you very much.
Thank you, sir. Okay, thanks everybody for being patient, especially during the session glitches. I would just like to say over here that as far as first session is concerned, there was no feedback form. Second session, we tried in MS Teams, but some of the participants were facing issues. So from now onwards, each and every feedback would be shared on WhatsApp. So I hope that will be easier for everybody. And attendance is automatically generated in MS Teams. So please do not worry about the attendance. If you are facing any technical issues, just send me on my personal WhatsApp message so that I can know that you are facing a technical issue and I can assign my IT faculty, IT staff to help you all out. Okay. So thank you all very much. We'll be meeting tomorrow. I'll just once again share the schedule so that we can see the lineup for tomorrow's lecture. Just a minute, I'm sharing the screen over here. This was the data that I was asking for problems. Yeah. Tomorrow 10 to 11:30, it will be a lecture by our head of department, Journey from Conventional to Electric Vehicles, where we'll be covering each and every aspect of this journey. Then 12 to 1:30, a lecture by Dr. Sudhakar Umale, who is professor from SP College. He will be taking vehicle dynamics from EV perspective. And 2:30 to 4, there will be a session on battery selection, sizing and simulation by Dr. Fanindra, who is manager in Prakriti Techniques India. So tomorrow, this is the lineup of lectures. So for today, that's all for today. We'll be meeting tomorrow, 10 o'clock. I request everybody to join beforehand and just take care. Since most of you are new, maybe new in Teams, so just take care when you join on Teams app. Just go to calendar and see the day-wise session that is being put. So tomorrow, day 2, session 1 will be the morning session. Just click in that meeting.